Stated Clearly presents What is an atom and how do we know? Atoms are the fundamental building blocks of chemistry. Just like baked goods are made of a collection of different types of ingredients, matter itself is made of a collection of different types of atoms. Scientists have discovered 118 kinds of atoms, which we call elements. You can find them laid out on a chart called the periodic table. All things from the screen this video is displayed on to the eyeballs with which you're watching it are made of atoms. But a single atom is so small, it is impossible to see with the naked eye. So there you have it. A random voice from a video you found on the internet claims that everything is made from invisibly small atoms. You may now blindly accept this as fact and happily move on with your day, right? No? Now you are extra curious? You want to know for yourself exactly why it is that scientists think they know that atoms exist? Well, to find out we must travel back in time to ancient Greece. Meet Democritus, the man that many historians credit for first clearly proposing the idea of an atom. In his day, it was thought by some that if you were to chop up a piece of matter, an apple for instance, you could just keep on chopping forever and ever. There was no end to smallness. For reasons not fully agreed upon by historians, this concept did not sit well with Democritus. Instead, he insisted that at some point, you would reach particles so small and so indestructible they could not be divided any further. He called them atomos, or atoms, which means uncuttable. Now, Democritus didn't actually have any evidence to back up his claim, and because of that, many people simply rejected it. After all, that which can be asserted without evidence can also be dismissed without evidence. Let's fast forward several hundred years. You probably know that salt can be extracted from seawater by simply letting it evaporate or boiling it dry. People have been doing this forever, but alchemist Jabir ibn Hayyan and those that followed his work took the science of extraction to a whole new level. Through careful experimentation, they developed complex processes of filtration, boiling, vapor collection, and cooling. They found that crude starting materials could be divided into multiple incredibly pure substances. Pure meaning they appeared to be consistent all the way through, unlike the complex mixtures of matter often found in nature. In the 1700s, a French husband and wife scientific duo, Marianne Poltz and Antoine Lavoisier, studied and built upon the work of their Arabic predecessors. They found that certain pure substances could be broken down even further through chemical reactions. Water, for example, can be boiled into steam, which is still water, but it can also be split into two pure gases, hydrogen and oxygen. No matter how hard the couple tried, however, they could not reduce oxygen or hydrogen into simpler gases. They concluded that the gases must be elements, foundational substances that cannot be created by mixing other chemicals together and cannot be broken down any further. With this concept in mind, scientists everywhere began searching for and listing as many elements as they could, eventually discovering all 118 listed on the modern periodic table. Some, such as oxygen and hydrogen, are gases at room temperature. Others are solids, such as elemental carbon and gold. Others still are liquid at room temperature, mercury and bromine. It was also found that under the right conditions, pressure and temperature, certain elements will react with each other upon mixing to form new substances with new properties. These are called compounds. The elements oxygen and iron can react to form a brown powder known as rust. Oxygen and mercury react to form a toxic orange powder. Oxygen and hydrogen react to form a clear, refreshing liquid. You probably know it as water. The steps may be complicated. All of these reactions can be reversed. Elements can be re-separated, and the amount of each element we get back after separation is always exactly equal to the amount that had reacted to form the compound in the first place. Wonderful. Elements are real, and they appear to be essentially indestructible, but what are they made of? If you were to zoom in on one, a chunk of pure gold, for example, Can you just keep zooming in forever and ever, saying nothing but pure gold for infinity? In the early 1800s, a school teacher from England named John Dalton grew fascinated with chemistry. Along with conducting several experiments of his own, he read about every experiment he possibly could, paying special attention to the quantities of each element used up in every chemical reaction. In these numbers, he was surprised to find a pattern emerge. When two elements can react to form multiple types of compounds, they always do so in small, whole number ratios. In this example here, we see that in order to transform a gram of carbon into pure carbon monoxide, we need to add 1.33 grams of oxygen. To turn a gram of carbon into pure carbon dioxide, we need to add exactly twice as much oxygen. That's 2.66 grams. This, and many other similar observations, strongly suggest that oxygen and other elements are made of tiny, indivisible units. Atoms. He didn't know exactly how small an atom was, but the numbers suggested that the atoms of a single element were all nearly identical in size to each other. A 60-page book that briefly mentioned his discovery. It even came with some quite beautiful drawings. While scientists weren't fully convinced that atoms were real, they did find the concept of atoms extremely useful. It helped them make accurate predictions and perform cleaner chemical reactions. In 1905, Albert Einstein, hold on there, in 1905 he was quite a bit younger than that. There we go. In 1905, Albert Einstein proposed an experiment and produced an equation that could be used not only to confirm the existence of atoms, but to determine exactly how big they are. A few years later, French physicist Jean Perrin, or I guess in French that would be something a little more like Jean Perrin, used Einstein's concept to actually do the experiments confirming beyond reasonable doubt, at least to other physicists and mathematicians, that atoms do, in fact, exist. Now, if you happen to love math and possess an in-depth understanding of physics, then great. You can just turn off this video right now and go read his book. But for the rest of us, a little visual confirmation that atoms actually do exist would be nice, right? Unfortunately, individual atoms are far too small to be seen.
वीडियो को कुछ भी नहीं लिख सकोगे। अच्छा ये बहुत तफसीर है, ये बहुत ऊपर लेवल का है। सिंपल लिखो तो मैं ऐसी वीडियो के लिए सिंपल टेक्स्ट पढ़ो और 2-3 लाइनें लिखो बस।